Alright, hi guys, this is another linear law video. And sorry for late posting, I've been really busy. So this is a question that y'all can try out. And here are a few hints. Alright, I'll go through it now. So firstly, you should extrapolate the line and then you get this coordinate x over y comma 0. And just remember that 1 mark in an AMAP exam constitutes to roughly 1.5 minutes. So since it's a 6 mark question, this would take like 9 minutes. Alright, so you look at the information given in the question. They give you one coordinate and one gradient. So you sub in 0 minus 9 x over y minus 4 equals to negative 1 over 4. You make use of y2 minus y1. Then after you get x over y equals to 40, flip the whole thing. You power negative 1 and then you get 1 over 40. So that's the answer. Next, for step 2, you make use of y2 minus y1 again. But this time, you make the y coordinate a special one, like 1 over xy. By the way, you cannot put y, because for this one, no, you can put y, but it'll be easier to just make use of the axis, which is 1 over xy. So you just sub it in, and then you'll get to this step. 4 over xy equals to negative x over y plus 40. You can combine these two, and you'll get this. Notice that both left-hand side and right-hand side both have divided by y, so you can also cancel that. Then you multiply the x across, and you get 4 equals to negative x squared plus 40xy. Then from then on, you need to make y the subject, and you get y equals to 4 plus x squared over 40x, and that's your final answer. And just remember to answer the question. Alright, this is an exponential question. Go try it out first. Alright, firstly, I just want to say that for this one, my y-intercept may be a bit inaccurate, since my one actually exceeded the graph. But it's cause I couldn't have enough space, but usually graph paper will give you enough space. Alright, so this is my thought process. Since this is an exponential question, you need to apply your laws of logarithm. And the scale is already given, so you actually don't have to think about that. But for this question, I actually disregarded the scale because I want to make the graph bigger. But in the exam, do not disregard the scale, okay? And just remember that you need to read the question very carefully. They say there's one incorrect recording. So it's okay if your graph looks something like this. That just means they're on the right track. But if your graph is like perfect, oh then GG lah. Alright, since there are two constants, A and K, you need to be careful about which one is the gradient and which one is the vertical intercept. So this is my graph. And these are my answers. So the first step to do this is to reconstruct the equation, make it a linear law in the form of y equals to mx plus c. So you shift the 20 across because they ask you to plot a graph of ln t minus 20 against x. Then you use your product law here, and then you use your power law here. So finally you get ln t minus 20 equals to ln a minus kx. Just a reminder, right, that for your gradient you need to include the coefficient. So if it's negative k, this means, right, that you need to put negative k equals to your gradient. Then you get the value of k. You can't just disregard it. Alright, so these are your y-axis, x-axis, and your vertical intercept. Next, you need to reconstruct your table of values here. So for the y-axis values, you need to round it off to 3SF because there's no way a graph can be that accurate to like 4SF or 4dp. And it'll make it really hard. So after you get these, you just plot it on your graph. Just remember that for linear law questions, you're supposed to pass through all the centers of the crosses. If it goes something like this, I suggest that you should redraw it, because it should really pass through the center. Alright, then you answer the question. Part 1 asks you to say the incorrect recording and estimate its correct value. So I used a black dotted line for this, and then I got 20.329, and this is the actual plot. Okay, so that's the incorrect reading. Just remember that you cannot derive the correct t-value exactly from your graph, since your graph is not a graph of t against x, it's about ln t minus 20 against x. So you sub it in, then after you solve it, so you get t equals to 46.8. You run it to 3SF. Alright, next, for ln A, this is based on the vertical intercept. Yeah, mine should have been in the graph paper, but it's not. Anyway, I estimated that it's around 4.15. And just remember that ln is basically log base E. So you use that to get your A value, which is 63.4. Next, you draw a huge gradient triangle, and I use the green dotted line for this. Right, you find two pairs of coordinates. Then after you take y2 minus y1 over x2 minus x1 for the gradient. Remember earlier I said negative k? Yeah, this part you must be very careful. Then you get your k value. If the answer is exact in your calculator, just leave it in exact. Do not round it off any further. Alright. Then the third part of the question is is asking the time when the temperature of the coffee is 50 degrees Celsius. Again, you cannot just find it directly. So you sub in t equals to 50 and you get 3.40. So you look for 3.40 in your graph. For me, I used the yellow dotted line to represent this, and the x value I got was 17.15. Now this is, anyway, 17.25, yeah. So this is your final answer. And just remember put the unit, which is minute. Alright, so here are some general tips for linear law. Alright, we're almost halfway done for our prelims, so take care of yourself, study smart, and don't stay up too late to cram stuff. Wanna make your brain work slower. And be extra careful for math stuff. Alright, thanks for watching. Bye and good luck.